Hello my dear students, welcome back to Pen and Paper Chemistry on YouTube. And today we start off with the topic of carbon and its compounds. This is a topic which is more specific to the students of grade 10 in any curriculum, GCSE, ICSE or even CBSE, because it gives you a basic idea about what do we mean by organic compounds. Now, before we start with the lesson, as the name of the channel says, pen and paper, make sure that you have a pen and notebook ready with you so that you can take down notes for offline reference, especially when you don't want to spend time watching a video on YouTube. So, happy learning. Let's get started. Let us first understand the electronic configuration of carbon and how it affects its behavior. Electronic configuration. Configuration means arrangement. This is a term that you would have learned in your previous classes. Configuration, how are they arranged? How are the electrons arranged? And these are arranged according to the 2n square rule, wherein the first orbit can have a maximum of 2 electrons. The second orbit can have a maximum of 8 electrons. What is there? There's 4 only over here. Why have I put 4? That's because the total number of electrons which carbon has is 6. That is, its atomic number is 6. And we arrange these electrons in the orbits or the shells of the atom. So the electronic configuration of carbon is 2 and 4. Valence electrons, the number of electrons in the outermost orbit. If you see in the case of carbon, if this is the nucleus, this is the first orbit with 2 electrons and this will be the second orbit with 4 electrons. Now, which of these is the outermost orbit? Yes, the second one, and that is called as the valence orbit. That means the outermost orbit. Now, how many electrons are there in that orbit? 4. So, the number of valence electrons over here is 4. We also know the octet rule, that is, any atom in order to be stable requires 8 electrons in its outermost shell, in its valence shell, called as the octet, octopus. From that we have 8. Octagon, yes, right. So the number of electrons required to complete the octet. Now, how many more electrons does carbon need in order to complete the octet? Correct, it's 4. The number of electrons an atom needs in order to complete its octet is known as its valency. How is it going to fulfill that? We will see a little later. So the valency of carbon is 4. Interesting. That means, what does it mean? In order to survive in nature, it needs 4 friends. It needs to make 4 friendships. It needs to spend time with 4 friends. Oh, I got the spelling wrong. Right? I will stick to friendships rather than friend. Why? Let's see a little later. So that means the number of bonds. So friendships are the number of bonds. So the number of bonds which carbon can form is how many? 4. This property of carbon is called tetravalency. Tetra means 4, valency, the number of electrons needed. So that means it needs 4 bonds in order to help it to be stable. So please remember to highlight or to underline the word tetravalency over here because it is an important term, especially when you are preparing for your examinations. How do we define it? Is the ability of an atom. Now, because that ability is not just for carbon, it could be for other atoms as well. So, ability of an atom to form 4 bonds. In chemistry, for bonds, for the word friendships, we say bonds. To form 4 bonds, either to different or to the same atom, is what we call as tetravalency. I hope you are noting this down. Now, if carbon has to form 4 bonds, what type of bonds can carbon form? Now, if you've not already seen the videos on ionic and covalent bonding, I would request you to go through those first in order to clear your concepts about the same, because this is a very, very important topic and the very basic of chemistry. I will share the link in the description in order to help you to find the video on the channel. So, what type of bonds does carbon form? 2 options. Either it can form an ionic bond or it can form a covalent bond. What is an ionic bond? Ionic bond involves transfer of electrons from one atom to the other. Now, again, going back to the structure of carbon, it has got 2 electrons in its inner shell and 4 electrons in its valence shell. That means either it loses all these 4 so that it can have 2 electrons in its outermost shell, because then the outermost shell would be the first one. Now, do you think if you are asked to give away 4 favorite chocolates of yours, would you give them away so easily? No. The same thing happens for carbon. If it loses 4 electrons, that means it acquires a 4 positive charge. Now, losing 4 electrons is not possible as the positive charge increases so much. That means the power of the nucleus increases so much that it will. So, it is something like if your friend asks you for 1 chocolate, okay, you will be okay to share. 1, 2, 3, 4, you have 4. Now, your friend is asking for 1 chocolate, okay. Okay, your friend says, I want 1 more. A little reluctantly, you might give the second one. By the time your friend asks for a third one, no way will you be happy to give it away. The same thing happens for the electron over here. Remember that there are, along with the 6 electrons, there are 6 protons as well, which are strongly pulling the electrons towards themselves. If there are 6 protons, 6 electrons, there is equal attraction. Now, if you give away 1 electron, so 6 protons pulling on 5 electrons. Imagine it as a tug of war which is going on between the 2 teams. Now, 6 protons, 4 electrons, what will happen? Yes, the force of attraction is going to increase further. It will not allow it to lose electrons so easily. So, carbon is not happy to form cation. It's cation, ion with a cut, a positively charged ion. Let's see the opposite case. Okay, now you ask your friend instead that, okay, I am short of 4 chocolates. Will you give me 4? So this is the case over here. Now you're getting chocolates. Oh, that's a good proposition, isn't it? But you have 1 chocolate, fine. You have another chocolate, okay, still okay. But by the time you have a 3rd chocolate, for sure you're going to have an upset stomach, isn't it? You won't be able to handle it. The same thing happens in the case of C4 negative. That means carbon gaining 4 electrons. Meaning to say there should be an equal number of positive charges, protons. The opposite situation applies over here. To start with 6 protons, 6 electrons. Now it's 6 protons, 7 electrons. 6 protons, 8 electrons. Oh, it is getting difficult for the protons to handle the electrons. Correct? Because there has to be an equal force of attraction for the atom or the ion so formed to be stable. So in order to get 8 electrons in the outermost shell, it is difficult for carbon to undergo ionic bonding, because either it forms a cation or it forms an anion. Anion means an ion with a negative charge. N for negative, here anion, cation, ion with a cut. A cation is an ion with a positive charge. So what option do you have? You can't give 4 chocolates, you can't take in 4 chocolates. What option do we have? Yes, sharing is caring. So what happens over here is, it tries to share. They try to share electrons with other atoms. Now, how does it share? That is what we are going to see a little later. So, the thing that we learn is that carbon actually prefers to undergo covalent bonding. Covalent bonding. How do we show this covalent bonding? Now, this sharing of electrons between atoms is shown by means of a line drawn between the 2 atoms. And remember, one line means 2 electrons, one coming from each of the atoms which is involved in sharing. So, let's suppose I have carbon over here. We know that it has got 4 electrons in its outermost shell. This carbon shares 1 electron with hydrogen. Now the dot electron that I have shown is coming from the hydrogen, but that does not mean that the electron is any different between the carbon and the hydrogen. It's just to keep a difference. It's just to make it more clearer. It shares 1 chocolate with the other hydrogen. It shares, now they are, each one of them is bringing one electron with them. Now look at the beauty of this. Carbon overall has now got 8 electrons, and that is what we wanted. Remember, octet, it wants to complete its octet. Hydrogen, because it's a small atom, it is happy to have only 2, what we call as a duplet. Again, the finer understanding of this topic is in the video on covalent bonding and covalent compounds. Now, if you see over here, between carbon and hydrogen, they have shared 1 pair of electron, 1 pair of electron, 1 pair of electron, 1 pair of electron. So 1 pair of electron is shown by drawing a single line between the carbon and the hydrogen. Now look at how many bonds, that means how many friendships has this carbon formed. Yes, it has formed 1, 2, 3 and 4 friendships in all. Can it form more than 1 friendship with the other atom? Yes, of course it can. But the thing is that the second atom should also be happy to form 2 friendships. So let's take the case of carbon forming a friendship with oxygen. Oxygen has atomic number 8, 2 and 6 is its electronic configuration. That means it needs only 2 more friendships. It needs to share 2 electrons, which it shares with carbon. Now carbon overall can form how many friendships? 4. So 1, 2 and 3 and 4. Just keep noting. I know to start with it will not make sense, but by the second video I am very sure that you will start liking the topic. Okay, can carbon form 3 friendships? Let's try that. Let's see if there is any atom which is happy to do that. Nitrogen, atomic number 7, 2 and 5. How many more electrons does it need to complete the octet? 3. So here comes carbon and says, okay, I can share 3 with you. Now what is left? It needs only 1 more friendship, and this it can do with hydrogen. I am taking hydrogen because that's the simplest element over here. Have you noted this down? Are you writing it down? Please pause the video, write it down. Our next question: what atoms can form covalent bonds with carbon? As we have seen, there can be many different types of atoms. Hydrogen, another carbon, oxygen. Yes, see the single bond O. Is that possible? Yes, we will see how that is possible. Nitrogen, chlorine, sulfur. There are so many examples of atoms which can form bonds or friendships with carbon. How do we represent these bonds? As I have explained above, through the means of single, double or triple lines in between the atoms which are involved in a sharing of the electron. In our next video, we will be explaining a new term to you, that is catenation. We will be using the concept of tetravalency and applying it to the concept of catenation and how it works. So stay tuned, keep the same notebook so that continuity is maintained. See you in the next video. Thank you so much, Madam Pramila, for encouraging me to bounce back onto the channel. Thank you.